Hello champion, I'm teacher Adam. Today we're going to learn our unit of quadratics. We're going to learn how to expand and we'll learn different rules. So I'll start with expansion. So we said we have different ways of expanding algebra. Like for example, we said if you're given a square, let's say we want to investigate, you're given a square and we know that a square has equal length. All the sides are equal. Let's say a plus b and a plus b, centimeter. And then you're supposed to find the area. We say in finding the area, it will be side squared, length squared, and then that's a plus b squared. If you need to find it, a plus b squared, that's the same a plus b times a plus b. When you expand this, you'll get a squared plus 2ab plus b squared. This is what you get. But how did we end here? Obviously, we said a times a plus b times a plus b. So therefore, when you multiply a times a, you got a squared, and then a times b, you get ab, and then b times a, you get ab plus b squared. When you add this, you get a squared plus 2ab plus b squared. And then you end up with a squared plus 2ab plus b squared. This is called a perfect square. So we're going to investigate types of quadratic. This quadratic expression, you say when you expand two algebraic expression. When you expand two algebraic expression, you end up with a quadratic expression. Now, for example, let's see if you have x plus 4 squared. What do you get? In this case, you'll end up with x plus 4 multiplied by x plus 4. So if you expand this, x times x, you get with x squared, and then x times 4, it's plus 4x. And then 4 times x, it's plus 4x. And then 4 times 4, you get plus 16. This one, you end up with x squared plus 8x plus 16. So this gives you a quadratic expression in the form of y is equal to x squared plus bx plus c. Then you have x plus 5 square. This will give you x plus 5 multiplied by x plus 5. So when you expand this, you get x squared plus 5x plus 5x. That means x times x squared. X times 5, you get x 5x. And then 5 times x, you get plus 5x. And then 5 times 5, you get plus 25. This you end up with x squared plus 10x plus 25. Correct, you get something like that. Then you go to x squared plus 9. This will give you x plus 9 times x plus 9. When you expand this, it's x times x by using butterfly method. X times x or FOIL method. Some say it's FOIL. X times x, it's x squared. X times 9, it's 9x. 9 times x is 9x. And 9 times 9 is 81. You get x squared. 9x plus 9x is 18x plus 81. Correct. Now, with this understanding of expanding, we remember when we expand this, we end up with a quadratic expression. Now, this our quadratic expression in this form, you can use a perfect square method. How do you use perfect square method to get a quadratic expression? So let's go. Perfect square method. So perfect square method, we can use perfect square method to get rid of the parenthesis or bracket. We can use the perfect square method to get rid of the bracket. How? In perfect square method, we say we square the first term plus 2 times the product first term and plus the last term. Correct. How do we do this? We say x plus 4 square. This we say we square the first term plus 2 times 2 times the product of the first term and the last term plus the last term square. So first term square is x squared. 4 times x, the product of the first term and last term is 4x. So 4x then plus the last term square. So you end up with x squared plus 8x plus 16. Good. This is using the perfect square method to expand. If you have, what if you have x plus 10 square? This will be, you take the first term square plus 2 times the product of the first term and last term plus the last term square. X squared. X times 10 is 10x times 2, it is 20x plus 100. Correct. This becomes our answer. What if you have x plus 12 square? You say x plus, so you take the first term square, 2 times the product of the first term and last term plus last term square. When you do that, you end up with x squared plus 12 times x is 12x times 2, 24x plus the last term square, which is 144. X plus 11 square, this will end up with x squared plus 2 times the product first term and last term. Then you end up with x squared plus 22x plus 121. This is what you do. Okay, I'm also going to teach you how we expand when you're given a square that has the same variable but different sign. Let's say one of the length of this square, sorry, my square will be a little bit shaky. So you have the square that we say one is x plus 4, another one is x minus 4. So in this case, what do we do? So if you use our butterfly method, so this is called a difference of two square. So when you find, so we're told find the area. If we have to find the area of the square below. So finding the area, we say area is equal to side square. The side is x plus 4 times x minus 4. If you use our butterfly method or our FOIL method, x times x, you get x squared, and then times that, x times that is minus 4x, then plus 4x, then minus 16. You end up with x squared minus 4x plus 4x is 0. This gives you to 0. Then this be minus 16. So your answer will be x squared minus 16. This becomes your answer. What if now you have, you're given now find the area. Let's say you're given x plus 5 times x minus 5. You need to find the area. So in this case, you'll say x times x, what do you get? X squared. And then x times that, you say minus 5x, and then plus 5x, then minus 25. So you end up with x squared minus 25. In other words, when we have a square that has similar variables, one is x plus 5 and another one is x minus 5, and when you are told to find the area, if you're told to find the area, we automatically understand that if you're told to find the area, we automatically understand that if one side is x plus 5 and the other side is x minus 5, when you expand this, we'll end up with x squared minus 25. In other words, you can just take the negative side, the negative expression, and square each term. Just take the negative expression and then square the first term and square the last term. This is how you'll be able to solve it. Therefore, you end up with x squared minus 25. As simple as it is. So, what if now, with the same knowledge, you're told to factorize? If you're told to factorize, we understand that factorizing means you're coming from bigger to smaller. Like they want the two algebraic expression that were multiplied to get x squared minus 25. So you just say you find the square root of each term. Square root of x squared and the square root of 25, and then you put a bracket x minus 5, bracket x plus 5. That's it. That's what you do. So majority of these questions come to multiplication and understanding the quadratics. You have to come from this state. So we automatically understand there is two ways that we have a perfect square and a difference of 2 square. So we have a perfect square and a difference of 2 square. So a perfect square, with a perfect square, you square the first term plus 2 times the product of the first term and last term plus the last term square. That's what you understand. So you take the first term, for example, you have x plus 7. So you just take your first term, you square it, and then you ask yourself, what is 7 times x? 7x. So 2 times 7x. Then you take the last term, square. Yeah. So you can choose to do that. It makes you even go faster, as simple as it is. And then when you're told, when you have this now, x plus 7, a difference of 2 square, and x minus 7. To expand it, you can use your old method, which obviously with your old method, if you do that, you just say x squared plus 7x minus 7x minus 49. You have this. Plus 7x minus 7x, you get 0. You end up with x squared minus 49. This is what you end up with. But what if it's about now x plus, the same x plus 8, and then x minus 8? You just say you use this perfect a difference of 2 square method. You use a difference of 2 square method. You just square the algebraic expression with the negative. Just say x squared minus 8 squared. You end up with x squared minus 64. That's what you do. And you get your answer correctly. So that's basically what we're supposed to do. This is what we exactly supposed to do. So it's not a big issue. If you understand it, it becomes very simple and it's easier to be solved. If you're supposed to factorize, if you're supposed to expand, you just apply the same principle. Expanding and factorization should be done in that angle. So up to now, we know how to expand. You can use both methods. If this method is not good, like for example, if you're told to expand, let's say we are told to expand the following. You have x plus 3 and x minus 1. If this is hard, you can use the square method, whereby you know 2 terms will give out 2. So this is x, this is 3, and then this is x minus 1. So x times x, you get x squared. X times negative 1, you get negative x. And then 3 times x, you get 3x. Then 3 times negative 1, you get negative 3. You can use that square method. And then you just add. Say x squared minus x plus 3x minus 3. What do you get? You get x squared minus 2x minus 3. You see, you can use that. If any of this is hard and you're given 2, even say x plus 2 square, you don't know what to do. You basically have to think of this other method then. If it's okay for you, you can use it. X and 2 and then x and 2. So x times x, you get x squared. X times 2, you get 2x. Then 2 times x is 2x, and then 2 times 2 is 4. Then you can just say x squared plus 4x plus 4. And you end it like that. So see you at the top champion. Let's meet in my next math class. Bye bye.